Hello, listener at home. Welcome to Swapa's Educational Consult. In our today's class, we shall be treating complex numbers. Complex numbers. And the question before us is, the complex number z is equal to 4 plus I3. So we are asked to convert it from rectangular form to polar form. That means the question is already in rectangular form. Then we have to take it to polar form. How do we go about it? Now, the first thing that will come to our mind is, what is the formation of complex number in rectangular form? Formation of complex number question in rectangular form is z is equal to x plus iy. That is the definition of complex number in rectangular form. Z equals to x plus iy. X is real part. YY stands for imaginary part. Don't forget, complex number have two parts majorly. It always have real part and imaginary part. How do you recognize them? Real part is x, while imaginary part is y. It is having I. It is having high, letter I. But some people use letter J actually. So it depends on the author of the book. So some use letter I, some use letter J. So that is to differentiate between real part and imaginary part. Real part is standing out, ordinary heads, while imaginary part is having I. Now let's go back to the question. We want to convert from rectangular form 4 plus I3 to polar form. Now, whenever we are dealing with this kind of question, the first thing that comes to our mind is to take two major steps. One of the steps is to find the resultant or the modulus of this complex number. What is the modulus of this complex number? Z is equal to 4 plus I3. We want to find the modulus first. This modulus can also be referred to as resultant, or you call it magnitude. So it has three names. So depending on what you want, you can call it either modulus, or you call it resultant, or you call it magnitude. So all the three of them are the same. So it asks for us to find the modulus. We have R, which is on this formula, square root of x squared plus y squared. R equals to square root of x squared plus y squared. That is how to find our modulus. Then let us go and take our x and y from the question. We can see now from the question, x stands for 4, y stands for 3. So we have 4 squared plus 3 squared. And our r simply gives us square root of 16 plus 9. And what does that give us? That gives us square root of 25. And therefore, our r is now equals to 5. I believe you get it. Anytime you are converting from rectangular form of complex number to polar form, two major things have to be done. The first thing is to find the modulus of that complex number. Then the second thing is now to find the argument. Argument, which is angle theta. Argument, that is the second thing. After finding the modulus, then argument, which is angle theta, is the second thing. How do we get our angle theta argument? It gives us our theta is calculated in this way, as tan y divided by x. That means second function tan y divided by x. We all know y in the question and we know x. Let us just substitute appropriately. So therefore our theta is equal to as tan, what's our y? Our y is 3, while our x is 4. Therefore, our theta now gives us as tan, what is 3 divided by 4? 0.75. Then, what is now the second portion of tan 0.75? Our theta, which is argument, is now equals to 36.86 degree. 36.86 degree can be approximately equals to 37 degrees. So that is the argument. We are able to find our modulus, which is 5, and our argument, which is 37 degrees. Now our work is easier. We want to convert rectangular form of complex number to polar form. The polar form of complex number is written in this way: r cos theta plus I sin theta. Let us just substitute correctly. R for r, theta for theta. That is we want to just the polar form. Then z is equal to, what's our half here? Our half is 5 cos theta is 37 degrees plus I sin theta is still 37 degrees. We close it. That is the polar form. The polar form. That is the answer. I believe it's clear. We need two things: modulus first, then argument second. Then you can bring them together, then apply this formula. The formula for the polar form: r cos theta plus I sin theta. That is the formula. You substitute for r, which is modulus, then you substitute for theta, which is the argument. Also, in a situation whereby you are asked to convert from rectangular form to Euler form. Euler form. For us to find Euler form, just apply this formula. Z is equal to half exponential I theta. Substitute appropriately, and that is the final answer. When you substitute appropriately, Z is equal to, what's our half? Our half is 5 exponential I, our theta is 37 degrees. This is Euler formula. This is polar formula, and this is rectangular formula. The question, rectangular way, answer in polar form: 5 cos 37 degrees plus I sin 37 degrees. Then answer in Euler form: 5 exponential I 37 degrees. I believe you get it. If you don't understand it very well, please watch the video again, and don't forget to share this video to other groups. Then put your comments and likes. Thanks for watching. See you later. Bye for now.